In this class, we are going to learn about big data. What exactly is big data? What can be done with big data? What are the applications of big data? How do we handle big data? What is distributed computing? What is MapReduce? What exactly is Hadoop? What is Hadoop Sandbox? What is HDFS, Hadoop Distributed File System? So we'll try to get started with big data in this particular class. So before we start with big data, we'll try to understand what exactly is big data. So we have some conventional tools. By conventional tools, what we mean is we have some tools like SQL, Excel, Access, SAS, R. Let's call them as these conventional tools for handling the data. So the conventional tools have their own limitations. What are the limitations of these conventional tools? Let's say think about SQL. You have SQL or Excel. Can you think of running a query on a dataset that is as big as 20 million GB? The file size is not just 1 GB, 2 GB, 3 GB. It's not even 1000 GB. It is as big as 20 million GB. If the dataset, it is just one file. If we have one file of such size, can we run a query on that using a conventional tool, let's say SQL? Can we load this data onto SQL? Can you load this data onto Excel or Access? First of all, can you store it in one system? What if we get a new dataset like this on every day? What if we have to do analysis on this type of data on every day? What if we need to write all these complex queries on this type of data on every day? First of all, we need to ask a question. Anybody really handle such kind of data? Is it possible to get this much of data accumulated in one day? Is there any website, is there any company that is already gathering this much amount of data? Yes. Google almost deals with 20 petabytes of data every day. Now that was some years back. In fact, they are dealing with more than 20 petabytes of data every day. Google is collecting lots of data every day. Now running queries on one such data set which is of 20 petabytes on SQL, it is very difficult. Almost in 2008, Google used to process 20 petabytes of data every day. Now it would have been 10-fold or 20-fold. There are like Wayback Machine processes 3 petabytes of data, almost like 100 terabytes of data every month. That was in 2009. Facebook used to handle 2.5 petabytes of data in 2009. Now it is much more than that. eBay. There are so many examples where lots and lots of data is coming into the system every day. In fact, within 1 minute, there are so many emails that we are sending. There are so many applications on the mobile that we are receiving. There is so much of data that is generated by the smartphone users. There is so much of content that is uploaded onto YouTube, Facebook, Twitter. There is so much of data that is gathered by Amazon, Flipkart whenever users are buying something. There is so much of data that these systems like Android and Apple, they are gathering so much of data, app related data. There are so many blogs, Instagrams. There are so many places where data is generated, and it is not in small amounts. It's in very large amounts, like huge amount of data is generated in one day or in a minute. In fact, this is just in a minute, this much of amount of data is generated. Now the problem with conventional tools is that they have their own limitations. If you try Excel is a good tool for ad hoc analysis, but if you try to open a file which is 500 MB or even 1 GB, Excel starts hanging, like you won't be able to handle the data which is more than 1 GB in Excel on usual systems. SAS or R, these analytical tools, they tend to give it up when you try a data which is more than 2 GB file. Access can handle data or query up to 10 GB, but beyond that it is not really going to help you. In fact, SQL, a good, very strong SQL on a very supercomputer kind of system, SQL can handle data up to 50 GB, but beyond that, SQL will leave it. We won't be able to handle the data. So these are the conventional tools: SQL, Excel, Access, R, SAS. The conventional tools won't be able to handle this type of data that is coming rapidly within a minute or every day. There is so much of data that is coming up, and the conventional tools won't be able to handle this. So what exactly is big data? What is big data? So any data that is hard to handle using conventional tools and conventional techniques is called big data. Let's say, what is a conventional technique? Conventionally, if you just want to find like number of rows in, let's say, number of columns, or number of, what is an average of a particular column, if you want to find it out in usual method, you just have one way of doing it. You load the file and you find the average, or you find the number of rows. But if you do that same technique on a bigger data set as big as this one, it won't work. So any data set that is hard to handle using conventional tools and techniques is called big data. Big data is not just size, any data set. So what is the base definition of big data? Any data set that is very difficult to handle using conventional tools is called big data. So another way of looking at is any data set that is difficult to capture, curate, store, search, transfer, analyze, anything that you want to do, manipulate, transfer, transform. So anything that you want to do on this data set using conventional tool, or anything, any data that is difficult to handle such operations is called big data. So big data is any data set that is large enough or complex enough so that it will become difficult to process it using on-hand database management tools or conventional database management. Traditional data processing applications won't be able to handle that data. So big data, the scale is larger, that means the volume is too high, sometimes it is even complex. So your usual tools and techniques and algorithms, or even the hardware, software, they won't be able to handle big data. So that is the definition of big data. So what is a simple statement? Any data set that is difficult to handle using conventional data tools is called big data.